Okay, so we now moving on to 6.5, rhombi and squares. That's all the new vocabulary is today. A rhombus, the way I tell students what a rhombus is, it's actually a square that's hinged and pushed over. We've got new properties for a rhombus, and we've got properties that you need to know about a square. So let's move on, let's see what they are. Okay, so here we are with a rhombus, and as you can see, the main property is you've got all four sides are congruent. Don't have to have the same, well, opposite sides have to have the same slope, but all four sides must be congruent the same size. Okay, what's the difference between a rhombus and a parallelogram? Well, when you do the diagonals, as you can see, all four diagonals are right angles and your diagonals are perpendicular to each other. And then the second property of a rhombus is that when you put down the diagonals from each of the sides, that you actually get congruent angles. So 1 and 2 are congruent, 3 and 4. In other words, your diagonal becomes an angle bisector. And as per usual with everything, you've always got the proof that you've got to write. Okay, most, as you know, is given. What have you got to prove? Well, look, I mean, normally in diagrams you'll be given sizes and things like that, or algebra, so you can use it. But you know, here is a written one, and again we're breaking things down into triangles. So as you can see, they're doing it by SSS, and don't forget our little end one, CPCTC. Okay, so here's example 1. You're substituting in, as I said, you're given information. All right, you're told it's 82, you've got to find the rest. Well, you know, you do know from the definitions that your diagonals bisect an angle. So if one angle is 82, then the bisector must make it 41, but you've actually got to prove it, so make sure you do. Okay, and again, you've got further proof to do here. Okay, so what are you given here is question 1. You're told that BCD, this angle here, is 64 degrees, and what you're trying to find is BAC, that's this little guy here. So in other words, half of it, but you've got to prove it. So let's have a look at what you've got to do to prove. Okay, let's go back to, it talks about a quadrilateral. Well, the one thing you do know about a quadrilateral is opposite sides must be equal. Okay, so if BCD is 64, then BAD must also be 64. Angle BAD, that must also equal 64 degrees. Okay, and you know that AC is a bisector, so AC is a bisector, or definition of a bisector. Okay, so BAC, angle BAC must equal a half. Let's go back to what we've been given, angle BCD. Well, we know that that is a half of 64, so your answer's got to be 32 degrees. Simple. Okay, so on this page, what have we got? Well, we've got the definition of a square. It's got all A, B, C and D are all right angles. A, B, B, C, C, D and AD are all congruent. Proof of a square. Okay, conditions for them. Both of them, the diagonals will cross at right angles, and if you put a diagonal down, both of them will bisect the angle. So the actual properties or conditions for a rhombus is the same type for a square. Okay, so here's writing a proof. You know that you always write with what is given. Okay, what have you got to prove? Well, you know, you can use segment addition, that KP and PM are congruent, LP, PJ are congruent, so you can use that definition. You also know that they are isosceles triangles, so just using that information, you will eventually come down to the fact that it is a rhombus. And example 3 gives you an idea of what's the best thing to do with questions like this. Obviously you're given this excavation site here, but the first thing they do, draw diagonals. So you can then start using the diagonal information, the bisected information, the segment addition information to start proving your point. Okay, so question number 3, write a 2-column proof. You know where you always start. You always start with what is given. Okay, so there's your given statement, so I'm not going to bother writing that in. But what do you know? Well, BD must bisect angle B, so there's your definition of a bisector. So angle ABP must be congruent to CBP. Okay, so that's bisector, definition of a bisector. Okay, what else do we know? Well, both triangles, and we're talking about ABP and CBP, both are using BP. It's going back to BP is congruent to BP. That's the reflective property. Okay. What do we know? That AB, well, if it's a rhombus, then this side must be congruent to that, so we can put that in. AB is congruent to BC, because that's the definition of a rhombus. So what have we got? Now we've got to prove that we've got our 2 triangles, so we can do that triangle APB is congruent to triangle CBP. And how can we do that? Well, it's going back to chapter 4, it's side, angle, side. Okay, it's PB is your side, PBC is your angle, and BC is your side. So we've proved that your 2 triangles are congruent by SAS. So everything else, as you know, falls into place by CP, and that would be your final part. Okay, example 4, classifying quadrilaterals using geometry. You've got to determine whether it's a rhombus, a rectangle, or a square. Again, it's the same old saying that I keep saying: plot the points on a graph, and if you look at it from visually looking at it, you know it's going to be a rhombus. All you've got to do is prove it. Okay, how would you prove it? Well, you would do the distance formula. You've got the coordinates, so do the distance formula of KL and JM to make sure they're the same distance. JK and ML, same distance, and then also do the slopes. So if the slopes are okay, then you've got the fact that it's a rhombus, a rectangle, or a square. So it's distance formula and slope. And here's all the proof for how they did it in the textbook. Okay, so you step 1 do the distance formula, step 2 do the slope, check it out. And as you can see, it's not a rectangle or a square, so therefore it must be a rhombus. So let's have a look at number 6. Okay, if you plot number 6, what do you get? Well, Q is -2, -1, so that's going to be approximately here. R is -1, 2, which is going to be here. S is 4, 1, so let me just extend that there and put that about there. So there's S. And T is going to be 3, -2. Okay, again, do a drawing. Well, looks a bit like a rhombus, but the fact that S is at 4, 1 proves that it isn't. But you know the rule now, do the distance formula, and then do the slopes to make sure. But when you've actually done that, you will realize that this answer is no. It's not a rhombus, a square, or a rectangle.